So our chapter here is sex determination. So before we go to the sex determination, let us see the difference between the sex determination as well as sex differentiation. Okay. What is sex determination? Deciding the gender at the time of fertilization, or that particular characters who come by birth will come under here. That's the secondary sexual characters, which we can say at the age of puberty, testosterone for the secondary development of the secondary sexual characters in the male, estrogen for the development of secondary sexual characters in the female, that all the things will come under here. So what we are doing, that we should know exactly. And here we are going to find out the answer. Actually, in case of human being or in case of any organism, when does the sex is determined? When does the sex is determined? Okay, when does the sex is determined? So what do you say? When does the sex is determined? Let me give the options. At puberty, at the time of birth. What do you think so? When does the sex is determined? At the
At the time of birth.
At the time of birth.
no, we have third option. To know that only we started this chapter. During fertilization. That is the third option. Okay. So when does the sex is determined? At the puberty,
During birth.
or at the time of birth, or during fertilization? During fertilization. That we are going to prove it now. That we say, that we call it as sex determination, and the characters who come by the chromosomes, that particular chromosome will decide the sex, and that characters are said to be primary sexual characters. Okay, let's start the sex determination here. Here basically there are four methods in general. There are four methods we can say. In the animals, in the organisms, we'll have four methods. We are going to frame a table for them to understand easily, to understand much better. We are going to frame a table. This table will make us to know easily that four types of basic sex determination methods in the organisms. So let us start. Let me draw the table. Let me draw the table. So various types of classifications are there. I'll go with the plain one. Then after we'll go with so four tables we want here. The four. Here it is. Ready. There are four basic types of sex determination methods. XX, XO method. We can say XX, XO method. Okay, XX, XO method. We can say XX, XO method. Number one, XX, XO method. Number two, XX, sorry, ZO, ZZ method. ZO, ZZ method. XX, XY method. Seems to be confusing, but when we complete that, it seems to be, it will come very easy. ZW, ZZ method. ZW, ZZ method. Only thing you have to remember the headings. XX, XO method, ZO, ZZ method, XX, XY method, ZW, ZZ method. That the interesting thing to be remembered here, if you remember the headings, everything will be over. What I mean, in the given methods, the first one is always female. In XX, XO method, who is the female?
XX.
XX is the female. In ZO, ZZ method, who is the female?
ZO.
ZO. Like that, like that. Let us write here, let us write that, we'll write there itself who is male, who is female. In case of XX, this is female, and XO method, XO is the male.
Male.
Next, in the same way, ZO, ZZ method. The first is the female. That's why I said over. To remember only the heading. If you remember the heading, then everything will be over. Here in XX, XY method,
Female.
female. XX is the female, XY is the male.
Male.
Next in ZW, ZZ method, ZW is the female and ZZ is the male. Okay. So then let us take one example to do this. Let us take one example. So XX, XY, what these are? Allosomal chromosomes we can see. These are called allosomal chromosomes. That means for the formation of full organism, we should use the full organism like autosomes also. AAXX I added here. So AAXX female, AAXY male. We should take the gametes here. I'm taking gametes. AX, AX, female gametes, male gametes, AX, AY. Okay, male gametes, AX, AY. Now, let's make a small box here for them. Okay, so if the gametes are same, we can say homogametic. If the gametes are different, we can say heterogametic. So what do you think among the, this is the human being XXXY method along with Drosophila. What do you think? Who is homogametic in case female or male?
Female.
Female is,
Homogametic.
okay, very good. Female is homogametic, male is
Heterogametic.
heterogametic. Female is homogametic, male is heterogametic.
Heterogametic.
Yeah, okay, then let's start. Let's write here. This is AX we are writing and AX. What we are doing exactly? We are doing fertilization. We need one more line. Okay. So what we are doing here? Fertilization means AX,
AY.
AY. Now what we are doing? This is ovum. AX, AX, ovum. AX, AY, sperms. So we should write like this. If AX type of sperm with AX type of ovum, AX type of sperm with AX type of ovum, when it is fertilized, what is formed? Male or female?
Female.
AX type of sperm with AX type of ovum. What is formed? Female.
Female.
Very good. Okay. So AX type of sperm with AY type, AX type of ovum with AY type of sperm. What is formed?
Male.
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 So get back to our question. What we asked, when does the sex is determined? At the age of puberty or at the time of birth or during fertilization?
During fertilization.
Yeah, itself, by the fertilization itself it is happening. You see here, this is sperm, this is ovum. So AX type of ovum with sperm with AX type of ovum, that makes that AAXX female. Okay, then AAXX female. Next, AY type of sperm with AX type of ovum, AAXY male. So sex is determined during
Fertilization.
fertilization. Okay, so finally we'll close this with examples. The human being, human itself, one of the examples for this, human and Drosophila. Drosophila melanogaster, fruit fly, we use it to see. In that also the XXXY type of sex determination is present. Okay, so I think you got an idea what we have to do. This is a well-known one, that's why I started from here. In the same way, we have to do this. I think you'll be helpful to me. Okay, XXXO method. AAXX. What is AA? What I mean of AA, autosomes we can say. A, which are symbol for autosomes, is a A. What is O? O means 0. For example, that how to calculate this. How to calculate this? I'll show you. Just wait a minute. I'll show you here how to calculate the chromosomal number and autosomal number also. Okay. So wait a minute. Then I'm going to log in other in the mean period of time. Just watch that. Wait a minute. So, in the methods of the sex determination, the very important thing you have to remember that the headings. If you remember the headings, remaining if that one of the model, if you do, the remaining all are going to be with the same model. So that's why we can say it won't take much time for preparation. There is no time required for the preparation. It's over itself. Only thing you have to remember is heading. Heading is the only thing you have to remember. You remember the heading, everything will be over. But we need to see here how does that number will be calculated and how does XXXO is different from that ZO ZO. So do you know how many chromosomes are present in a human being? How many chromosomes are there? We said human XXXY method, human chromosome. So how many chromosomes are there in the human being? Okay, let me say there are 46 chromosomes in the human being. 46 means I am writing here uh, 46 chromosomes. In that we can say 22 pairs are autosomes and one pair is allosome. Who are called allosome? XX, XY are called as allosomes. XX and XY are said to be allosomes. Okay. So that we need to calculate that particular area like this. So I am writing here. So just watch this. AAXX. I am writing here like this. Okay. So how many chromosomes we said in case of human being? 46 chromosomes are present. Then in that 22 pairs are autosomes and one pair is allosome. One pair, XX, we can say. So out of 46, how many are over?
2.
So remaining 44. That 44 will write here. Okay, 22, 22. This is the way to calculate. So now you see 22, 22 pairs, 44 autosomes, 45, 46. So I think you got this. So let me practice the same in case of Drosophila. Okay, human male also. So male 1, 1. So what is A equal to? Autosomal pair. In case of male also 22, 22 means 22 pairs of autosomes and one pair of allosomes. Otherwise, we can say 22, 22, 44 plus 2, 46. Here also you have to apply the same. For example, you see, we said this is the gamete. AX type of ovum. That means 22, 1. AY type of sperm. 22, 1. So what is fertilization? These autosomes of mother, these autosomes of father. That means ovum and sperm will become 22 pairs. They don't decide any sex because autosomes are same in both male and female. So next, one allosome from the mother, X. One allosome from the father, Y, decides the sex. What we said, sex determination done by allosomal chromosomes. X and X or X and Y are going to decide this. So what is this then? Male. So this is the way to calculate. Okay, now let me give the number of the chromosomes in the Drosophila. In Drosophila, chromosome number is 8. Now try to find out. The same method is same. XX, XY method. So we should write like this. AA, XX, AAXY, male AAXY. So, okay, so try to find out. Allosomal number is always 1. Value of each allosome. So, let me write X, X, 1, 1. So, how many remain?
XY.
Out of 8 chromosomes, ఎన్ని మిగిలాయని అడుగుతున్నాను. Total 8 అండి. Out of 8 chromosomes, 1, 1. అయిపోయింది.
6.
6. That means we should distribute like 3 plus 3 plus 1 plus 1. ఇది ఎలా రాస్తామండి? We'll write like this. 3 pairs of autosomes, 1 pair of allosomes. అలా రాస్తాం. Okay, here also the same. 3, 3, 1, 1. So total number of chromosomes in case of Drosophila. Let me say in human being again. Total number of chromosomes in human being are 46. Let's go to the next page. Total number of chromosomes in the human being are 46 chromosomes. Okay. So in that 22 pairs are autosomes. 22 pairs are autosomes. That means somatic chromosomes that represent only somatic characters of the body, like hair color, height, color, that everything of the body except reproductive organ. Remaining one pair is called as allosome. One pair is called allosome. Okay, so 22 pairs are autosomes and one pair is called allosome. What are the 22 pairs? We represent, we show in the form of AA. A means autosome. So each A equal to, otherwise we have to write this A for 22 times, this A for 22 times. That means 44 A's we have to write. Instead of that, we are making abbreviation. Then one pair of allosome. What are they? XX. If XX is there, that will be female. 22 plus 22, 44, 45, 46. That means chromosomes are 46. Next, in case of male, AAXY, 22, 22, 1, 1. That is 46. Okay. So that's it. What do you say? This condition as a chromosomal number can be distributed like this. Okay. Next, Drosophila. Total number of chromosomes in the Drosophila are 8. 8 means 4 pairs. That means actually no problem when we are doing when we are writing 8 marks question or 4 marks question. But this kind of distribution you should learn when you are writing competitive examination, either NEET or Ncert. Okay, so determination in case of Drosophila, AAXX, AAXY, XY method. We can say simply 4 pairs. Among this, 1 pair is XX, 1 pair is XY. Okay, then remaining 3. So like this. Okay, when we take the gametes, it will come like this. 3 plus 1, AY, 3 plus 1. Okay, so that again they become AAXY, 3, 3, 1, 1. That means again 8 chromosomes can be seen. This condition we say haploid condition. Due to meiosis, it occurs. Haploid condition. Okay, so when we take the gametes, I'll show you again. When we take the gamete, this is diploid organism. Diploid organism. I'm showing this in human being. 22, 1, 1. 22, 22, 1, 1. Total 46. So gametes you said AX, AX. Gametes you said AX, AY. Okay. So here in this case, A equal to 22, 1, 22, 1. That means in haploid gamete, we'll find 23 chromosomes. Half of the chromosomes only present. 23 chromosomes. Here also. 22 plus 1, 22 plus 1. During fertilization, when these two gametes are, that means this is ovum and this is the sperm. When they are fertilizing, that leads to AAXY. That means 22, 22, 1, 1. Okay, so that makes the fertilization. Got it? Got my point here? So this is the general information you should know. Now let's get back. Let's get back. Here, mostly our text is focused on homogametic and heterogametic condition. Okay. So among the XX, XY method, who is homogametic, who is heterogametic? Now you can see by looking toward the diagram. So what is homogametic? What is homogametic? If the two gametes which are formed here equal, we say homogametic. If they are not look like same, we say heterogametic. You just decide who is homogametic, female or female.
EAXX is homogametic.
Yeah, this is homogametic. Formed gametes are similar. That's why
Homogeneous.
what do you say that as homogametic condition?
Homogametic.
Yeah, who is homogametic here?
AXX.
No,
AXX.
female or male?
Female.
Female.
Female is homogametic. Then who is heterogametic?
Male.
Male.
Male is heterogametic. Okay. So description, no need to write. Just you can, if you frame the table, you just if you frame the table, the remaining everything is in the table is explaining everything. You see here. So let me write. Let me say XX XY method. XX XY method. In XX XY method, XX is the female, XY is the male. Then the female is homogametic, male is heterogametic. We can say female is homogametic, male is heterogametic. Okay. Next. So during the fertilization, AX type of sperm with means this side female, AX type of sperm with AX type of ovum makes the formation of AAXX female. Next, AX type of sperm with AX type of ovum with AY type of sperm form AAXY male. Okay, if I ask you that who is the deciding factor in human being, male or female?
Male.
Male.
Yeah, and always heterogametic is going to be the deciding factor. Got my point? Now, let's start this. Let's start here. Here also, the same. Let me take the gametes first. Female eggs. Okay. Next, male. What are the gametes and the male? Egg.
AXO.
AO.
What is O? O means zero. O means zero. This is actually first time it was identified in a bug called proteinor. Let's take a description and let's get back. In the case of proteinor, the 14 chromosomes are present. In female, 14 chromosomes. In male, 13 chromosomes are only present. Female is with 14 chromosomes, male is with 13 chromosomes. Let us see how is it possible. 1, 1, that means 6, 6, autosome. 6 plus 6, 12, 13, 14. Then here, this is the condition. Here the determination of the sex is little different. If two X chromosomes are present, that is female. If only one X chromosome is present, that is male. Just for our not to confuse, we are putting that word O. O means zero. That is not O even, that is zero. That don't have any value. So that's you see here. 13 chromosomes in the female, 14 chromosomes in the female. That is a special type of determination. We can say XX, XO type of determination. Okay. So we can say like this. During the gamete formation, autosome with allosome, there it is autosome without allosome, we can say. Okay. That is special one. That is a special thing that you may have learned over XX and XY earlier, but this is a new and special thing here. And with these, you people need to understand all the organisms in the world are not with the same kind of determination. They have their unique ways of determination. Okay, I'm making box for you to go for this XX, XY method, XX, XO method. We can say this kind of sex determination, making box to put all of them. And again, the same question. Who is heterogametic here? In
Male.
XX, no, female or male? You should answer like
Male.
Male.
or male. Same like there also, here also, the female and male. Female is homogametic and male is going to be heterogametic. Okay, so let me take another color. AX autosome with X chromosome. AO autosome without X chromosome. Okay. So now, can you say like this? Here we should make some. This is female this side and this side male. Okay. Now you try to answer here. Fertilization. X type of sperm.
AAXX.
Yeah. AAXX. So what it is? Female or male?
XX.
Female or
Female.
female? Very good.
AAXX.
AAXX. What is this?
Female, female.
Female. Okay.
Female.
AAXO. What is this?
AAXO.
What is this?
Male.
Male. AA.
Male.
That. Now again the same. Who is homogametic? Who is heterogametic?
Homogametic.
Female is homogametic. Male is heterogametic.
Female is homogametic. Again, same. There here same.
Male.
Female is homogametic. Okay, and male is heterogametic.
Heterogametic.
Okay. ZO, ZZ method. Actually, this is even called XA. In that you can use, but to avoid the confusion, we made like this. ZO, ZZ. That means XO, XX. We have to say. To avoid the confusion, they did like so. Okay, now say answer fast here. AA, ZO. Okay, then here AA, ZZ. Who is ZO?
Female.
Female. Then gametes in the female.
AZ. AO.
So, who is heterogametic then?
Male.
Female.
AZ. AZ.
Please that.
Male is a heterogamete.
చూడండి జాగ్రత్తగా చూడండి. Here seems to be simple. That's confusing.
Female is the heterogamete. Male is the homogametic.
Yeah, female is a heterogametic and male is a. And do remember only one basic required here. First is the female. Ladies first and అది గుర్తుపెట్టుకుంటే చాలు. First female, then male. Okay, and that means you should remember the headings in that particular manner. Okay, so here female is heterogametic, male is going to be homogametic. Okay.
Homogametic.
Yeah. Hello. Let's start here also. Then after we'll fill that. Let's start here also. Cheppandi. AAZW. What is that? AAZW. Male or female?
Female.
Yeah. AAZZ. Okay. Next. Gametes. AZ.
AW.
AW. So, who is heterogametic? Who is homogametic?
Female is heterogametic. Male is homogametic.
Yeah. In ZO ZZ method, in ZW ZZ method, female is heterogametic, male is homogametic.
Homogametic.
In XXXO method, in XXXY method, female is homogametic, male is heterogametic. So what to do? Simple again the same. That we need to make the table and we should fill the table. Okay. We should fill the table as usual. Nothing new. The same routine. We should say we take female gametes on one side and male gametes on other side, and we should write AZ type of sperm with AZ type of ovum will form AAZZ zygote. What is AAZZ? Theoretical question is going to be make some confusion here. I am writing. Okay, so one side will take the female and other side male. I'm writing here female AZ AO. Okay, next male AZ AZ. So you just say here what it is. AAZZ. What it is?
Male.
Male. Very good. AAZO.
Homogametic male.
Gametes
Female.
gamete అండి. హోమో హెటెరో అన్నది మీరు గ్యామెట్ లోనే వాడాలి. Only gamete. Now it is zygote. Okay, next. AAZZ. What is this?
Female.
Male.
Male. AAZO.
Female.
Female.
Female. Now, here again. One side female gametes, other side male gametes I am taking. Okay. Next, AZ, AW. AZ, AZ. Okay, we are taking AAZZ. What is this?
Male.
AAZW.
Female.
Female.
AAZZ. What is this?
Male.
Male.
AAZW. What is this?
Female.
Female.
Yeah. So now examples. So these kind of AZW method we can see in case of birds, reptiles, and some fishes are having these kind of birds, reptiles, and some fishes are having ZW, ZZ method of sex determination. We can see, as we said already, in case of human being and Drosophila, XX, XY type of sex determination is present. Okay, now let us see XX, XO method of sex determination. Okay, sir, I am writing examples here. XX, XO method. We can see bugs. In some bugs, we can see this grasshopper, in case of grasshopper, and in some cockroaches also we can see XXXO method of sex determination. XXXO method of sex determination is seen in the bugs, grasshopper, and as well as that in cockroaches also you can see this kind of sex determination. Now let us see where the ZO, ZZ type of sex determination. In case of moths, and some butterflies also, we can see this kind of sex determination. Moths and some butterfly. Butterfly is moth or similar kind of animal here, insects, we can say. So this is the complete the methods of sex determination here. XXXO method and oh, wait, lost it. XXXO method, ZO, ZZ method, XXXY method, ZW, ZZ method. Okay. Okay. So seems to be easy, but you have to practice yourself. Okkasari practice cheyalandi. Without practice, you don't get this actually. Okay. Along with the examples, you need to make the practice of this.